When you're talking about the Large Hadron Collider and physics experiments at this level, the key word is energy. What they're trying to do there is mimic, approach the energies that happen at the beginning of the Big Bang. When all the energy that was released, some of it stayed energy, a lot of it turned into matter. And so if you want to understand the nature of that matter, you need to pull it apart and have a good look at it. And you do that by banging particles into each other that smash into their constituent particles, elements, even smaller and smaller and smaller subatomic elements. And you need huge energies to do that. You're accelerating protons, the building blocks of atoms, around this ring at near the speed of light and smashing them into each other. And they fly apart, revealing all the constituents and other elements and energies that make up matter in the universe.
And why is this research so important?
Well, if we want to understand our place in the universe, we need to get as deep down as we can get. And in order to do that, you need these energies. And that's what they're doing. They're upgrading the injectors that fire the particles. They're not upgrading the magnets so much as retraining the magnets that direct these particles, so that you can get these higher and higher energies. And also they're getting higher collision rates, because when you're doing these experiments where maybe 1 in 1,000 times you get the result you want, you need to do them many, many, many times over and over again. And, the answer to why are we doing it is, if we want to understand the universe, our place in the universe, we need to get as fundamental understanding of it as we can. It's called the Standard Model. And what these guys are trying to do is break the Standard Model to see if it holds up to everything they can find out. Everything we know about the universe is all lumped together in this idea of the Standard Model.
So what kind of timelines are we looking at here?
I won't see it. It's impossible to know, because each time they do something, they find out something else. Until 2012, the Higgs boson was something on an equation. And then the Large Hadron Collider proved it. The things that are going to be very interesting in the next in the next few years, I was talking to a physicist at CERN, not involved with the Large Hadron Collider, but with the antimatter factory, which we're going to visit on Razor in a couple of weeks, which I'm very excited about. He said the raison d'etre for the Large Hadron Collider now is to try and discover dark matter. Dark matter in that Standard Model that I was talking about, and dark energy, are the bits we know have to be there, but we have no idea what they are.
But the answers to the universe are years and years and years, decades away.
We may never get all the answers to it. As J.B. Haldane said, the universe is not only very strange, it's far stranger than we can imagine.